Okay, let's write this integral. Here's the problem point right here. So let's write this as the limit as r goes to 0. As the integral 1 to r, x to the minus 1/2. And integrate minus 1/2 plus 1, divide by 1/2, or multiply by 2. All right, let's substitute in here. Substitute in 1 minus, substitute in r. Okay, now as r goes to 0, this second term goes to 0. So this limit's equal to 2, and the integral converges. Here we have the same integrand that we had in the previous problem, but different limits. So here we have an infinite limit, which makes this improper. And we'll replace that with an r. And we'll do the limit as r goes to infinity. Okay, when we integrate, add 1, divide by 1/2. Okay, let's do that. Now we're substituting in r. As r goes to infinity, this is the square root of r. It's also going to infinity. So this diverges. In number 25, we have the integral from minus infinity to infinity of 1 over x squared plus 4 dx. So let's use r again. And this is an arctan integral. And that would be 1/2 arctan x over 2. And now let's just go ahead and substitute. So we have arctan r over 2 minus 1/2 arctan minus r over 2. And we're sending r to infinity. So as r goes to infinity, arctan is approaching pi over 2. So this first term over here is approaching 1/2 pi over 2. And the second term as on the left here as minus r goes to minus infinity, arctan is going to minus pi over 2. So this is going to 1/2 minus pi over 2. Okay, so we have 1/2 pi over 2, and this is minus minus, that's plus 1/2 pi over 2. So that's equal to pi over 2. Let me just remind you for a second what the arctan graph looks like so you can see why we have these limits. Here's the arctan graph. Okay, so we're looking at y equal arctan x. Okay, we have a horizontal asymptote at the top and another one at the bottom. At the top at pi over 2 and at the bottom at minus pi over 2. And arctan is approaching pi over 2 on the right, and it approaches minus pi over 2 on the left. Okay, so that's where we got these from. If you take a look at number 26, the top and the bottom are almost equal. They just differ by 1. So as x goes to infinity, it looks to me like this quotient is going to 1. This 1 over here is not very significant. The numerator is almost equal to the denominator. So it looks to me like this should definitely diverge, just looking at the integrand over here. All right, well, let's integrate this. This is actually a log integral. The derivative of 1 plus e to the x is e to the x, so the derivative of the denominator is sitting in the numerator. Okay, so let's rewrite this as a limit. R goes to infinity. Okay, so we have the log of 1 plus e to the x. And substitute in. And we have the log 1 plus e to the r. Minus the log of 1 plus e to the 0. That's 2. 1 plus 1. All right, well here we have the log of 1 plus e to the r. Now e to the r is going to infinity. And loosely speaking, the log of infinity is infinity. So this is also going to infinity. So this integral diverges. Okay, here we come to the last problem in our review, problem 27. We have a parabola, y equal 8x squared plus 16x plus 10. And we want to find the focus, the vertex, the focus, and the directrix. So we'll put this in standard form. All right, we'll start by completing the square. So let's factor out the 8 from the x term. So here we have x squared plus 2x, and I'll leave a space here. Okay, now let's take half of 2, half the middle term, that's half of 2 is 1, square it and we get 1. So we're going to add 1 and subtract 1. These three terms are the perfect square, so let's write it as a perfect square. And let's multiply through here. Now we're going to isolate whatever the square term is, the x plus 1 squared. So let's write y minus 2 is equal to 8, x plus 1 squared, and now divide by 8. So we have 1/8 y minus 2 is equal to x plus 1 squared. Okay, this is standard form where the completed square is on one side, isolated by itself. All right, in that form, this, whatever's before the y minus 2, that is 4p. So we have 4p is equal to 1/8. Divide both sides by 4. And we have p is equal to 1 over 32. Alright, so now that we have this standard form, we could get some information out of it. Like, for example, here's the standard form. We could get the vertex. So let's do that. The vertex is -1, 2. And now the focus. This is a parabola with an x squared term. It's an up-down parabola, facing up-down. So to get the focus, we add p onto the y-coordinate. So that's -1, 2 plus 1 over 32. And to get the directrix, we subtract p from the y-coordinate of the vertex. So that would be 2 minus 1 over 32. Okay, that's the end of the review. Good luck studying.